You'd think a GPS-guided missile would hit exactly where you tell it to. And you'd be wrong, sometimes by a lot. Picture this. You're firing a $100,000 Excalibur artillery shell that's supposed to land within 10 meters of your target. Instead, it decides to cosplay as a lawn dart and plants itself 200 meters away in someone's potato field. Or take the GBU-31J Dam, a 2,000-pound GPS-guided bomb that normally hits within 13 meters, but suddenly has the accuracy of a drunk meteorite when Russian Zhidal jammers start broadcasting. Welcome to modern warfare, where your precision munition just got outsmarted by electronic warfare. Modern guided weapons can be deadly accurate, unless someone's messing with their brains. And in that regard, militaries are trying to make lobotomies great again. Let's rewind to 1991. The Gulf War was basically GPS's coming out party. Before that, precision meant dropping bombs somewhere in the same zip code as your target. The Air Force was still using gravity bombs with the aerodynamic efficiency of flying refrigerators. Then GPS showed up and suddenly we could drop a J-dam through someone's kitchen window from 15 miles away. Well, not quite a kitchen window, more like within 30 feet of it. But compared to the old days when close enough meant the same city block, this was revolutionary. GPS-guided munitions work by combining two systems: GPS for real-time positioning and inertial navigation systems, INS, for when GPS gets moody. Think of INS as your weapon's internal compass and accelerometer. It knows where it started and tracks every twist and turn. GPS is the helpful friend constantly texting updates. Turn left in 500 meters, target ahead. But here's the thing about GPS. It's essentially a satellite whisper. Those signals are so weak that your microwave oven puts out more electromagnetic noise. A GPS satellite broadcasts with about 50 watts of power from 12,500 miles up. By the time that signal reaches your bomb, it's weaker than a dying flashlight, which makes it incredibly easy to jam. Enter electronic warfare systems like the Russian R-330ZH Zutel, a truck-mounted jammer that can disrupt GPS signals across a 30-kilometer radius. GPS jamming isn't rocket science. It's easier than rocket science. The ANMLQ-40, profit-enhanced system used by U.S. forces, can detect and jam enemy communications, but similar technology works against GPS. Some jammers are so simple you can build them with off-the-shelf components. Though the effective military-grade systems like the Chinese DZ-2 GPS jammer cost around $50,000. When a GPS-guided weapon loses its satellite fix, it falls back on its INS. This is where things get interesting. INS is like asking someone to navigate to a restaurant while blindfolded, using only their sense of direction. It works fine for short distances, but the longer the journey, the more it starts to wander. A GBU-31J dam might start with 13-meter accuracy under GPS, but once it's flying blind on INS alone, that accuracy drops to 30 meters or worse. The smaller GBU-38J dam fares even worse, normally achieving 5 to 10 meters with GPS, but becoming essentially a very expensive unguided bomb when jammed. And sometimes the jamming is so effective that the weapon doesn't just miss, it gives up entirely. Picture a $100,000 Excalibur artillery shell that's supposed to hit within 10 meters of its target. Under heavy jamming, it might as well be a very expensive firework that lands wherever physics decides. Ukraine has become the world's largest electronic warfare testing ground, and the results are eye-opening. Both sides are jamming GPS signals so aggressively that entire regions have become GPS-denied zones. The Russians deployed truck-mounted Zytel jammers, as well as the even larger RB-109A Bylina units. The Ukrainians responded with their own jamming systems, including captured Russian equipment and Western-supplied electronic warfare platforms. The result? Some of the most advanced GPS-guided weapons in Western arsenals are struggling to stay smart. M31 rockets fired from HIMARS, designed to hit within 5 meters of their target, are sometimes missing by hundreds of meters. M982 Excalibur artillery shells have had their effectiveness degraded so much that production was actually reduced. Even Russian Iskander missiles and Kaliber cruise missiles aren't immune. Ukraine's electronic warfare systems have turned some of Russia's unstoppable weapons into very expensive lawn darts. Let's talk about the delivery systems because context matters. The B-2 Spirit bomber, America's $2.1 billion stealth flying wing, was designed to penetrate Soviet airspace and drop nuclear weapons with pinpoint accuracy. Today, it's dropping JDAMs on Iranian nuclear targets, and even the B-2 isn't immune to GPS interference. During the June 2025 strikes on Iran's nuclear facilities, B-2s flew missions from Missouri to hit underground facilities, including the heavily fortified Fordow enrichment complex. The strikes were successful, but they could only be done confidently after weeks of Israeli strikes that degraded Iran's air defense networks. Perhaps they could have been successful either way, but in a conflict with China or Russia, it would be much less of a guarantee. Then there's the F-35 Lightning II, the Pentagon's $100 million flying computer. It can carry GPS-guided bombs internally to maintain its stealth profile, but what happens when those bombs can't find their GPS signals? The F-35's advanced sensors can help, but it's still dependent on the same vulnerable GPS constellation as everyone else. Now, like everything else, drones are changing the GPS jamming game in unexpected ways. While GPS-guided bombs are getting jammed, drones can provide real-time laser designation for laser-guided munitions. A drone can fly close to the target, paint it with a laser, and guide a bomb to impact even when GPS is completely jammed. The MQ-9 Reaper drone, for example, can carry both GPS-guided Hellfires and laser-guided variants. When GPS is jammed, it can switch to laser guidance and still deliver precision strikes. It's like having a backup plan for your backup plan. But here's the twist. Drones themselves are vulnerable to GPS jamming. Ukrainian forces have reported GPS jamming so severe that their drones start flying in circles, completely confused about where they are. The solution? Some drones are now equipped with optical navigation systems that can recognize terrain features, essentially flying by landmark recognition instead of GPS. Before we dive into GPS alternatives, let's talk about why militaries keep switching guidance systems in the first place. Every guidance method has its Achilles heel, and the enemy is always trying to find it. Laser-guided weapons like the GBU-12 Paveway 2 or GBU-24 Paveway 3 can be defeated by something as simple as smoke. The Paveway system employs a modular design that transforms unguided general-purpose bombs into precision-guided munitions with laser seekers and control fins. But Russian tanks carry 3D6 smoke grenade launchers and Shtora-1 systems that disperse aerosols specifically designed to block laser designators. It's like trying to paint a target with a laser pointer through a fog machine. Infrared-guided weapons like the AGM-65D Maverick missile hunt heat signatures, but they're vulnerable to flares and heat decoys. The AGM-65 Maverick is an air-to-ground missile designed for close air support, with TV, imaging, IR, or laser-guided variants. Modern aircraft carry flare dispensers that can fire dozens of decoy flares hotter than the aircraft's engines, essentially giving heat-seeking missiles multiple choice questions they usually get wrong. Radar-guided weapons like the AIM-120 AMRAAM face the oldest electronic warfare tricks in the book. AMRAAM uses two-stage guidance when fired at long range, with the aircraft passing target data to the missile before launch. But chaff dispensers drop clouds of metallic strips cut to precisely interfere with specific radar wavelengths, making one aircraft look like 1,000 targets. Russian Su-35s and Chinese J-20s carry sophisticated radar jammers that can make AMRAAM shots miss by feeding false target information. The kicker? Modern countermeasures are getting so good that some weapons carry multiple guidance systems just to have backup options. The Israeli Spice 2000 bomb combines GPS, INS, and electro-optical guidance in one package. A single missile might use GPS for initial guidance, switch to radar for mid-course correction, and finish with infrared terminal guidance. It's like having 3 different ways to ask for directions, hoping at least one of them work. The military is scrambling to find GPS alternatives, and some of the solutions are genuinely clever. Terrain contour matching, TERCOM, allows cruise missiles to navigate by comparing the ground below to stored elevation maps. It's like having a GPS system that works by looking at mountains instead of satellites. Then there's stellar navigation. Yes, bombs that navigate by the stars. The military is developing systems that can identify star patterns and use them for navigation, just like ancient sailors. It sounds ridiculous until you realize that stars can't be jammed, spoofed, or shot down. Some newer systems are experimenting with quantum navigation, using quantum sensors to detect minute changes in gravitational fields. It's incredibly accurate and completely immune to electronic warfare. The downside, it's currently about as practical as navigating by interpretive dance. GPS spoofing is jamming's evil twin. Instead of blocking GPS signals, spoofing feeds fake ones to the receiver. It's like giving someone incorrect directions while they're driving. They think they're going the right way until they end up in the wrong state. The scary part about spoofing is that the weapon thinks it's working correctly. A GPS-guided bomb might be flying confidently toward what it believes is its target, completely unaware that it's been fed false information. It's precision-guided incompetence at its finest. Here's some brutal math. A GPS jammer costs about $50,000. A single JDAM costs about $25,000. An Excalibur artillery shell costs $100,000. A single jammer can potentially defeat dozens of expensive munitions. It's the ultimate asymmetric warfare tool. Spend thousands to waste millions. The Pentagon is now spending billions on assured positioning, navigation, and timing systems. Basically GPS alternatives that work when GPS doesn't. Meanwhile, jammers are getting cheaper and more effective. It's an arms race where defense is more expensive than offense, which is usually a bad sign for the defense side. During the 2022 invasion of Ukraine, Russia's initial strategy relied heavily on precision-guided munitions to avoid civilian casualties and maintain international legitimacy. When those munitions stopped working reliably due to electronic warfare, Russian forces switched to area effect weapons and traditional artillery. The result? Cities like Mariupol and Kharkiv were subjected to indiscriminate bombardment instead of precision strikes. GPS jamming didn't just affect military effectiveness, it may have contributed to the conflict's shift towards civilian targeting. On the flip side, Ukraine's electronic warfare capabilities have forced Russia to adapt. Some Russian cruise missiles now carry multiple navigation systems as backups. Others have reverted to older, less precise guidance methods that are harder to jam but less accurate. The military's response to GPS vulnerability is creating a new generation of multimodal weapons. These munitions don't just rely on GPS. They combine GPS with inertial navigation, terrain matching, optical guidance, and even artificial intelligence. The latest JDAMs include anti-jam GPS receivers and can switch between different guidance modes automatically. Some experimental weapons can even recognize their targets visually, using AI to identify specific buildings or vehicles. It's like giving a bomb a set of eyeballs and a brain. But here's the catch. The smarter the weapon, the more expensive it becomes. A basic JDAM costs $25,000. A multimodal smart weapon might cost $100,000 or more. At some point, you're spending so much on individual munitions that you can't afford to use them. Amid all this high-tech warfare, the human element remains crucial. Ukrainian drone operators have learned to fly their aircraft manually when GPS is jammed, using visual references and dead reckoning. It's like going from driving with GPS to navigating with a paper map. Possible, but requiring much more skill. Similarly, artillery crews are relearning old-school firing techniques for when GPS-guided shells don't work. Forward observers are becoming more important again, providing real-time targeting information when automated systems fail. The irony is that the more we rely on automation, the more valuable human skills become when that automation fails. It's a reminder that technology is a tool, not a replacement for training and experience. The GPS jamming problem isn't going away. It's getting worse. As jamming technology becomes cheaper and more available, even non-state actors are gaining the ability to disrupt GPS-guided weapons. Terror groups and insurgents who couldn't afford surface-to-air missiles might soon be able to afford GPS jammers. The response is a new generation of weapons that don't depend on GPS at all. Hypersonic weapons, for example, can navigate by inertial guidance alone over short distances. Directed energy weapons, lasers, and particle beams don't need navigation systems at all. But perhaps the most important development is the recognition that precision warfare isn't just about having smart weapons. It's about having weapons that stay smart in contested environments. The future belongs to munitions that can adapt, overcome, and complete their missions, even when someone's trying to make them stupid. We spent decades and billions of dollars making bombs smart, and they've performed as advertised against adversaries that aren't equipped with jamming capabilities our next opponent may have. The modern battlefield isn't just a test of firepower, it's a tech support nightmare at 800 miles an hour. Your $1 million smart bomb just got outsmarted by a $50,000 jammer, and now it's flying around like a confused tourist without a map. But here's the thing about arms races. They never really end. For every new jamming technique, there's a new counter-jamming solution. For every spoofing system, there's an anti-spoofing response. The cycle continues, driven by the eternal military truth that if you can build it, someone else can break it. And that, folks, is why even the smartest bombs sometimes get the dumbest results. The only constant in warfare is that nothing stays constant for long. Subscribe to Steel Mallard for more tactical truths from the only bird in the fight that never misses.